Hi folks, due to some technical issues, I've had to just stop that last video where it was, and so I'm just going to finish off what I've done here. I'm just finishing off this example. I've sketched the graph of y equals 2 sine 2 bracket x minus pi on 3 minus root 3. Okay, so that process there that I went through is sketching the graph. I was finding the x-intercepts, and not only did I lose a bit of focus, so the video got a bit slow, but I also had some technical issues that I had to sort out. So what I'm actually doing here, and I'll finish this off for you, is I'm actually working through and finding the x-intercepts of this graph. Okay, here we have the x-axis. It's up here. Okay, I've got these values in here because that was sketching it. Just have a look at the end of the last video. But we need to find what these x values are. So the equation is y equals 2 sine. I've got that up here. That's the equation. What I'm doing here, and I'll move this down now, is I'm making that equation equal to 0. When I make that equation equal to 0, the negative 3 can come over to here, and this 2, if you divide both sides by 2, the 2 comes here as well. So you get sine 2 bracket x minus pi on 3 equals root 3 on 2. So if the sine of this equals root 3 on 2, then this has to equal pi on 3. That's one of the solutions. Okay, I've drawn a quick little standard triangle in here. This is the equilateral triangle with the side lengths of 2, 2, and 2. When you split it in half like that, that's a 1. So that's 2, that's 1. That length there is root 3. Sine is opposite over hypotenuse, so this angle here, this is 60 degrees or pi on 3. Now, if that equals pi on 3, okay, but there's another angle where that equals pi on 3, and it equals pi on 3, and it also equals pi minus pi on 3. Because we want the angle in the second quadrant as well, so it equals pi on 3 and 2 pi on 3. Now that's between 0 and pi. There are two solutions, but we want solutions between 0 and 2 pi, because up here you've got 0 and 2 pi. So there's solution 1, solution 2, we need solution 3 and solution 4. Okay, so this one here, you've got to add pi to this, so this becomes 4 pi on 3. Sorry, you don't add pi, you add 2 pi. You add 2 pi. So it's 7 pi on 3. So it's one full revolution of the circle, that's why it's 2 pi. So this is 7 pi on 3. And then adding 2 pi to this one here, we have 8 pi on 3. So what we've come up with there is that these are the 4 values between 0 and 2 pi that are the x-intercepts, but actually we haven't solved for the x-intercepts. What we've got here is 2 bracket x minus pi on 3 equals these 4 solutions. So this 2 here has to come down to here, so we have x minus pi on 3 equals pi on 6, 2 pi on 6, 7 pi on 6, and 8 pi on 6. So then what we have to do is we have to add pi on 3 to all of these. Okay, so when we do that, you've got sorry for the pause there, I got interrupted. So you've got, what we're doing is we're adding pi on 3 to all of these. Okay, so or what pi on 3 is 2 pi on 6. Okay, so pi on 6 plus 2 pi on 6, 2 pi on 6 plus 2 pi on 6, 7 pi on 6 plus 2 pi on 6, 8 pi on 6 plus 2 pi on 6. I'm adding pi on 3, which is 2 pi on 6. I'm adding that to all of these. So I'm doing this the slow way. So this is 3 pi on 6. 2 pi plus this is 4 pi on 6. This is 9 pi on 6. Okay, and this is 10 pi on 6. When we simplify these fractions, this is pi on 2. This is 2 pi on 3. This is 3 pi on 2. Okay, and this is 5 pi on 3. So we got there in the end. These are the 4 solutions to this graph up here. So these are the coordinates of these points. That one, that one, that one, and that one. Okay, so we've done it. We got there in the end. Look, I hope that helps. Have a look at the worked example as it's presented in the book. Have a look at what I've got here. Have a go at the questions. And as always, ask your teacher if you need help. Thanks, guys.